This numerical is based on PVT relation in thermodynamics subject asked in the GATE examination during the year 2018. The problem statement along with the figure necessary to solve it is shown. You can read. The data given are the mass of the piston in the figure. Piston is shown here and its mass is 25 kilograms and its area is 100 centimeters square. Initial pressure of air inside this piston cylinder arrangement is 200 kPa. Temperature of the air initially is 400 degrees Celsius. Ambient pressure, that is the pressure above the piston, is 100 kPa. Ambient temperature is 27 degrees Celsius. What we need to find? It is the temperature at which the piston will begin to move. So initial temperature is Ti. That's why a notation T suffix F is used. What is the physical meaning of this one? There is air inside a piston cylinder arrangement. Because of the air pressure and temperature, the piston moves up. It is held in a particular position using stoppers. Suppose if the temperature of this air is increased, at one particular temperature, the piston will try to move up. What is the temperature at which it will try to move? That is the question and solution. When the piston is about to move, volume remains constant. The question is, what is the temperature? When the piston is about to move or when it begins to move. So at the moment when the piston is about to move, there is no change in volume. Therefore, volume remains constant. What is the pressure volume temperature relation for a constant volume process? This is the one. This can be rewritten as Tf is equal to Ti multiplied by Pf by Pi. Pi initial pressure is given. Ti initial temperature is given. But what is the final pressure Pf? It's not given. Therefore, our first aim is to calculate this Pf using the data provided and then calculate what is Tf. When the piston is about to move, the force on the piston due to air pressure in the cylinder is balanced by the weight of the piston and ambient pressure. It is represented schematically here. Below the piston is the air pressure shown in red color. Initial pressure is Pi, and when the piston is about to move, the final pressure is P suffix F. On the other side of the piston, that is on the top side, there is a pressure due to piston weight. So that is what given here, weight of the piston, balanced by the weight of the piston. In addition to that, piston pressure, meaning pressure due to the weight of the piston, ambient pressure is also present. Therefore, the total pressure acting on the top of the piston is equal to P suffix P plus P suffix infinity. And the total pressure acting at the bottom of the piston is P suffix F. For the piston to move upwards, Pf must be greater than the sum of P suffix P and P suffix infinity. But we are interested in the moment the piston is about to move upwards. At that moment, this final pressure P suffix F must be equal to the sum of these two pressures. P suffix infinity is given in the problem, but what is the pressure due to the weight of the piston we need to calculate. Pressure exerted by the piston due to its weight P suffix P is equal to piston force divided by area of the piston. Area of the piston is given, but what about piston force? Force is equal to mass times acceleration due to gravity. So piston force is equal to mass of the piston multiplied by acceleration due to gravity. Mass of the piston is given and acceleration due to gravity g is also given. Therefore, we can substitute. That gives piston force is equal to 250 newtons. From this, we can calculate what is P suffix P. So 250 divided by 100. 100 is the area of the piston. And this 10 power minus 3 is to convert this 250 newtons into kilonewton. 10 power minus 4 is to convert area in centimeter square into meter square. We get 25 kilonewton per meter square. At the moment the piston is about to move, final pressure P suffix F is equal to summation of P suffix infinity and P suffix P, which yields 125 kPa. Now we can use the relation between pressure and temperature for a constant volume process, substituting the known values. We can identify the unknown T suffix F, which yields 420.63 Kelvin, which is equal to 147.63 degree Celsius.